Hey everyone, Mr. Voikin here, and we're going to do another breadboarding tutorial here, and this one is going to focus on the capacitor, and in particular a type of capacitor called an electrolytic capacitor. Now I've already got the breadboard set up and ready to go. So we have our 9 volts connected up to the top rail, which is basically setting up this line right there. We've got our ground in, and we still need to put in our switch so that we can load up the ground rail as well right there. So we'll do that very quickly here. So I'm going to grab a power switch, and just like we've done in the previous videos, I'm going to connect the common leg to the incoming ground, and then terminal 2 I'm going to run through a diode. So we will switch this over here to all components, grab a diode, type R a bunch of times to spin it in the proper orientation, and run that down to ground. So now we have that portion of the circuit complete. So let's head over and grab a LED. And I'm going to show you 2 different ways to breadboard this up, because I always Command Z. I always set my breadboard up, with the positive rail up top and on the bottom, and the ground rail up top and on the bottom. But I think all the circuits I've done so far, I've ran all the V plus up to the top and all the ground down to the bottom, which is pretty standard, but I might as well show you how we can utilize the entire board here. So let's go grab an LED, and we will pop that in right here. Okay, now it says we're going to run the negative leg down to ground, which we would do as we have in the past, just straight down to ground right there. Now normally what I was doing was I was taking the resistor and jumping it across the middle there, then running it eventually up to the V plus. But because V plus is right down here on the bottom as well, connected through those jumper wires, I can just put it in like that. It just cleans it up, minimizes any jumper wires that we need, and anytime you can eliminate jumper wires and connections, especially on a real breadboard circuit, you're going to reduce the number of spots where we could have bad connections. So I just need to change this to ohms and follow the schematic, which says 470 ohms, and we have created that circuit down there. Now, like I said, I could have run it up like this and then taken a red wire and jump that up to V plus. So both of those are fine, but again, we've decided to utilize it in this fashion this time. Okay, well, let's deal with this capacitor. So it's an electrolytic capacitor, and generally electrolytic capacitors, which means they are polarized. So one end is going to be positive, as you can see right here. It says it's got a plus up top, and the down does not have a minus sign, but it would be the negative side of the capacitor. And on a capacitor, just like an LED, it has a long leg and a short leg, and the short leg is indicative of the negative side, and the longer leg would be the positive side. But what if it's in a circuit board, or the leads have been cut, and you should just double check that the stripe is leading down to that leg right there, which will always be the negative. Because the capacitors are polarized, they have to be connected the proper direction, and they can be quite dangerous if connected backwards. They can actually blow up and be quite dangerous. So we are going to put this one into our circuit like so, and we'll change it its capacitance value. Now, according to the schematic, it is 1,000 microfarads. So The negative leg, as we can see, is connected down to ground, and the positive leg is connected directly up to V plus, and I can do that with just a couple quick jumper wires down here on the bottom, like so. And that is our completed circuit. Now, how does it work? Well, essentially, once the power is connected, the electrons are going to travel through the switch down through the diode into this bottom rail, and they're going to shoot up into the capacitor, and the capacitor will store these electrons as a charge. And once it's full, it just sort of doesn't accept any more charge. Now, because the electrons can also travel over to the LED through a parallel branch, it's going to go up through the LED, back down through the resistor, where we're going to slow it down to an acceptable current, and again it's going to go into the positive rail and back to the battery on the positive terminal, and we have a completed circuit. Now, what does a capacitor do? Well, I already said it stores these electrons in the form of a charge, but essentially once it's on, like, well, I got to run the simulation. Once I turn it on, you can see the LED goes on, and once I turn it off, what will happen is I'm now going to cut off the sort of the current that is going to be supplied from the battery, and now this charge that was in the capacitor, we say the capacitor discharges and releases those electrons, which will come back out and run through the LED circuit and back to the battery as it did when it was connected. So let's just turn this off, and you can see it's off, and slowly the LED fades. Now, if I change the value of this to say 4700, in theory it should stay on longer. So I'll stop the simulation, start it, crank up the power, LED goes on, turn it off, and you can see the LED takes a little bit longer to go off because there's more charge inside that capacitor, so it takes a little bit longer to drain. And that's the circuit. Hope this helped.